Today I did legs. Started out with squats, not too heavy, just regular squats. Then I did single leg RDLs. Followed that with leg extensions and leg curls. It's about 4 to 10 for each step. And then I did lunges, weighted lunges, and that was a good workout. That I used glycolysis and did throughout the workout. I was fine. Glycolysis, went to the Krebs, into electron transport chain, and then but once I got to the lunges, weighted lunges, I started using lactate. My system's couldn't keep up. I need energy right there and then because those were very hard workouts. But really, I needed blood to my legs the whole time, so I used how the blood flows through the heart from into the lungs to give oxygenated blood to the capillaries to get oxygenated blood into my muscles directly, and so that's how it relates to the class for leg day. Today's workout, I did ultimate frisbee. It was a very ongoing workout using my VO2 max, probably about 85. But really how it relates to the workout into the class is my cardiac output. I needed blood right there and then. And from using, cardiac output really depends on my heart rate and my stroke volume. And so for heart rate, I use the sympathetic system, use the EPSP, I use the alternator nerve, and with that increasing, it increased my cardiac output, and also with stroke volume, my contraction of me moving for an hour or two also increased the cardiac output, getting the blood and more blood through my system into my muscles, so I can make them work. So today I had an intramural soccer game. I ran about 4 miles, and really how it relates to my class is for my legs and my cardio. Basically, it really was based on my cardio output, the amount of blood going through my body. That really depends on my heart rate and my stroke volume, which were both increased through the sympathetic system and stroke volume with contraction, afterload, and preload. But during exercise, my sympathetic nervous system was initiated, and which that was a response with my body. My body met the demand of needing more blood, and through the blood, it went to my capillaries, to my muscles, getting my muscles oxygenated blood, and that's how I kept going today. Today I did chest and triceps. We started out with a flat dumbbell and then incline bench, and then I did some chest flies, and then ended up doing triceps and doing tricep pull downs, and also skull crushers. I finished out with some push-ups and then some abs. And today I'm talking about what our body system went through. It went through glycolysis. Instead of going all the way through Krebs cycle and ETC, I really was thinking I was really needing more energy throughout the workout, and so it went towards lactate. Lactate it goes through there because the capillary blood to end up being bicarbonate and then going into higher acid, making carbonic acid. And from carbonic acid, it goes to our lungs, we exhale, and that's where it goes back into glycolysis and goes through the cycle, making more pyruvate. Today I did back and bi. I started out with lat pulls, lat pull downs, and then ended up with some rows, about 4 sets of 10 on all those, and then did back and then biceps. I did curls, preacher curls, 4 sets of 10, and then what I want to talk about was the fixed equation today for VO2 max during our workout, which is really dependent on our cardio output and then our concentration in our atrium, and the concentration of oxygen, and all of this is really dependent on two things: is our increase in mitochondria, which so we can handle more, and then our increase in our capillary density, which increases the amount of oxygen we can uptake and use at one point, which is by the number of mitochondria we have. So that's what was increased for our concentration of the atrium and concentration of oxygen. And then with the increase in our heart rate for our cardiac output and our increase in exercise for our afterload, it increases. So increase our VO2 max. Today was more of a cardio / legs. I might work on my friend. We did a big workout where it was a lot of more movement of the legs, like step ups, and then we did wall sits, and we did in the air squats on the wall, holds. And what I want to talk about is how my body reacted to this workout and how it responded. It really responded with the depolarization of the neuron. It was initiated from knowing that I did a workout, so it depolarized, and so the actual neuron, the dendrites, received the signal of working out. It depolarized down through the cell and depolarized from the cell down the neuron all the way to the end, where receptors were released to be released into the motor plate, and actually went and depolarized my muscles to contract. We use it through my sarcomere, where calcium was released and binding to troponin and toward myosin moving, being able for myosin to grab actin and actually contract, and using the next ATP, being able to contract all the way. Today I played basketball, bigger size, just like more of a cardio, so my VO2 max was high, whereas basically the amount of oxygen I can consume. And today I want to talk about the cardiac output and how much blood I needed through my body while I was playing. With the increase in my heart rate today, using my sympathetic system, I use that with my accelerator nerve, and also with stroke volume. My afterload was pretty hard, so that was increasing my contractibility for my contraction with my legs and my body. Increased my stroke volume, which at all increases my cardiac output and the blood I had going through my muscles and my body. Today I did chest and triceps. It was really simple workout. Bench press 4 to the 10, incline dumbbell 4 to the 10. I did dips, about 3 sets of 10, tried to at least. And then for triceps, I did skull crushers, and then I also did tricep push downs. And for today's workout and how it goes to the class is talking about our twitches we had. So we have twitch 1, type 1, type 2N, type 2X. And so for the twitch we used today was the fastest twitch, which is 2X. Basically, 2X is more for the anabolic system, and it's more fatigable. And this is the fastest one, which means the speed of the contraction we had. Type 1 is usually the slow contraction, just more the aerobolic system, but a little bit more reliable for just regular day stuff. So for today's workout, we used type 2X. Today I did back and biceps. For back I did rows, and then also I did lat pull downs and lat pulls. For biceps I did curls, and I also did hammer curls. And all of this was through the system of glycolysis, and it was a pretty slow workout, so I went through glycolysis. I also went through Krebs cycle and ended up going to ETC. All this is happening on our mitochondria. Being able to have the system going in our mitochondria is the powerhouse of our cells to have more energy. what I did to actually help out the system was increasing the amount of mitochondria we have, which increases the amount of energy we can actually hold and use at one time, and actually more mitochondria. We can increase the amount of oxygen uptake we have to help us work out and actually help us perform. Today I did legs. I did a lot of single leg stuff. I did single leg press, single leg RDLs, and after that I did leg extensions and leg curls, and then it ended it with some goblet squats and stuff. And today I'm talking about phosphocreatine and how I was using that in my heavier lifts. And so once I actually initiated an exercise of when I needed a lot of energy right there and then, my ATP was initiated and actually stimulated my phosphocreatine, or my creatine kinase, to break down phosphocreatine to then resynthesize ATP, to actually use all that energy and to get that fast energy, and that's the quickest energy to get. Until it was all gone, I had to wait for ATP actually to come back.